Welcome to Science Snippets, Fun Facts, and Trivia. Today, we bring you Why is the Sky Blue? Unveiling the deep mystery behind a simple phenomenon. Have you ever looked up at the sky on a clear day and wondered why it's blue? It is something we encounter every day, yet most of us take it for granted. The bright blue sky stretches above us, a seemingly simple part of our world. But behind that familiar color lies a complex and fascinating scientific story. In ancient times, people were just as intrigued by the sky. They saw it as something mysterious and divine. Philosophers like Aristotle thought deeply about the natural world. But even the greatest thinkers of their time were puzzled by the color of the sky. Some believed the sky was simply a reflection of the vast ocean. Others thought it might be a window to the heavens, a view into the unknown. For centuries, this question went unanswered. It wasn't until the development of modern science, particularly in the field of optics and physics, that we started to gain real insights into this everyday phenomenon. By the 19th century, scientists began to understand how light and the atmosphere work together to create the colors we see. The key discovery was that sunlight is not just one color, but made up of many different wavelengths. These different wavelengths of light interact with the particles in Earth's atmosphere, creating the colors we perceive. But why does blue dominate? It turns out that the answer lies in the way light is scattered by the molecules and tiny particles in the air. This scattering effect, known as Rayleigh scattering, is the main reason our sky appears blue. While the question may seem simple, the answer opens the door to some of the most fundamental principles in physics, showing us how something as ordinary as a blue sky is the result of incredibly complex natural processes. Now that we know sunlight is made up of many colors, we can start to understand why the sky appears blue. The key lies in a phenomenon known as Rayleigh scattering. This process occurs when light travels through Earth's atmosphere and interacts with the gases and tiny particles that make up the air. But what exactly is Rayleigh scattering? Sunlight, or white light, is made up of all the colors of the rainbow. Each of these colors is actually light at different wavelengths. Blue light, for example, has a shorter wavelength, while red light has a much longer one. As sunlight enters our atmosphere, it collides with air molecules like nitrogen and oxygen. These molecules are incredibly small, much smaller than the wavelength of visible light. When sunlight hits these tiny particles, it gets scattered in all directions. Here's where it gets interesting. Shorter wavelengths, like blue and violet, scatter more easily than longer wavelengths, like red and yellow. So, as sunlight passes through the atmosphere, blue light is scattered far more widely across the sky than other colors. But why do we see blue and not violet, which scatters even more? That's because our eyes are more sensitive to blue light, and much of the violet light is absorbed by the upper layers of the atmosphere. This scattering process is happening all around us, all the time. It's why the sky is filled with blue light in every direction. When the sun is high in the sky, what seems like a simple, everyday sight is actually a stunning example of how light interacts with the world around us, revealing the hidden complexity of nature in every clear blue sky. While the sky is blue during the day, it changes to stunning shades of red, orange, and pink at sunset. What causes this shift in color? The answer still involves Rayleigh scattering, but with an important difference. As the sun lowers toward the horizon, its light has to travel through a much thicker portion of Earth's atmosphere before reaching us. When the sun is overhead, light takes a shorter path through the atmosphere, allowing the shorter wavelengths, like blue, to dominate what we see. However, as the sun begins to set, the light takes a much longer path through the atmosphere. During this longer journey, the blue and violet light is scattered out of our line of sight. What remains are the longer wavelengths of light, such as reds, oranges, and yellows, which are less affected by scattering. As more blue light is scattered away, these warmer colors begin to fill the sky. But why do some sunsets appear more vibrant than others? The answer lies in the atmosphere itself. If there are particles like dust, smoke, or pollution in the air, they can scatter even more light, enhancing the red and orange hues. Similarly, water droplets in the air, like those found in humid conditions, can also contribute to the intensity of a sunset. This is why sunsets in some regions, or after certain weather events, like wildfires or volcanic eruptions, can be especially vivid. This daily transformation from blue to red reminds us that the same sky can take on completely different personalities, depending on the angle of the sun and the conditions of the atmosphere. Our sky is a beautiful shade of blue, but what about the skies on other planets? Are they blue as well, or do they reveal something entirely different? The color of the sky on any planet depends on the composition of its atmosphere and the way that light interacts with it. Earth's atmosphere is made mostly of nitrogen and oxygen, which scatter blue light effectively. But other planets have very different atmospheres, leading to a wide range of sky colors. Take Mars, for example. Known as the red planet, you might think that its sky would be red as well. However, the sky on Mars is typically a pale, dusty orange or butterscotch color. This is because the thin Martian atmosphere, made mostly of carbon dioxide, is filled with fine dust particles. These particles scatter light differently, creating a soft reddish or orange hue, especially during the day. Interestingly, during sunrise and sunset, the Martian sky can appear blue due to the way dust scatters the sunlight at lower angles. On Venus, the sky is entirely different again. Venus has a thick atmosphere full of sulfuric acid clouds, which create a dense yellowish haze. The sunlight that reaches the surface of Venus is heavily filtered, giving the sky a bright, sulfuric yellow appearance. The thick atmosphere traps so much heat that the planet is one of the hottest in the solar system. Then, there are the gas giants, like Jupiter and Saturn. These planets don't have a solid surface like Earth, Mars, or Venus. Instead, their atmospheres are composed of hydrogen, helium, and other gases. The skies of these planets appear deep, swirling shades of blue, orange, brown, and white, depending on the atmospheric layers and cloud patterns. The stunning blue of Neptune's sky, for instance, is caused by the scattering of sunlight by methane in its atmosphere. Each planet offers a unique view of the sky, giving us clues about its atmospheric composition, weather, and even its history. Studying these otherworldly skies helps scientists understand the vast diversity of conditions in our solar system and beyond. So why is the sky blue? It turns out that the answer reveals a lot more than just the color of the sky. The blue we see is the result of sunlight scattering through Earth's atmosphere, with shorter wavelengths, like blue, being scattered more than others. Rayleigh scattering gives us the familiar blue sky during the day, and at sunset. The changing angle of the sun allows red, orange, and pink hues to take over. But the sky's beauty doesn't stop there. From the deep blue skies of Neptune to the pale orange skies of Mars, each planet tells a different story through the color of its atmosphere. Every sky in the solar system holds clues about the planet's composition, atmosphere, and even its climate. Back here on Earth, the simple question of why the sky is blue shows us the complexity of nature. What seems like an everyday, ordinary sight is actually the result of physics, light, and the unique properties of our atmosphere, working together in perfect harmony. The next time you look up at the sky, take a moment to appreciate the intricate science behind it, whether it's the clear blue of a sunny day or the warm glow of a sunset. The sky above us is a constant reminder of the beauty and complexity of the natural world. If you found this video helpful or interesting, please give it a thumbs up and subscribe to the channel.